The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody. My name is Sharon Dooley, and I'm going to do a brief introduction, and then I'll turn the floor over to Matan, our speaker. I'd like to thank our sponsor, Dell Software. They make it possible for us to give you a door prize at every one of these meetings. And we'll announce the raffle winner at the end. I didn't update this slide today. I should have, because there are a lot more SQL Saturdays going forward. This only lists the ones in the very near future. You can find out about them at www.sqlsaturday.com. And this is a schedule of some of the meetings. I've left them in even though they've already happened, because they may be the virtual chapters may be of interest to you. There are a whole bunch of virtual chapters at SQLpaths.org. You can sign up for any of the ones that you are interested in and get notifications of when they're doing a presentation. We are always looking for volunteers. There's all sorts of things you can do. If you have a volunteer that you want to nominate, excuse me, I suddenly got a frog in my throat, nominate for an outstanding volunteer of the month, send your nominations in. And at the Paths Community Summit, there will be a Passion Award that's presented every year to a volunteer who has made significant contributions to Paths and the global data professional community. Membership in Paths is free. I'm assuming most of you are members, since that's how you learned about this. But if you're not a member, go to www.sqlpaths.org and sign up. And I didn't change the title on this, my bad. The presentation is on Small Changes Make a World of Difference. And our presenter is Matan Youngman. He's a technical evangelist for Madeira SQL Server Services. He has years of experience working with SQL Server, and he also co-hosts an Israeli SQL Server radio show. He's passionate about SQL Server technology and the SQL Server community. And without further ado, I'll turn the meeting over to Matan and let him do his thing. And
Okay, thank you, Sharon. Can you see my screen?
Yep.
Great. So first of all, thanks a lot for having me, Sharon. And thanks a lot for joining us. Yeah, okay.
Okay, I thought I lost your audio. There we go.
So everything good now?
Yep.
Great. Great. So thanks again for joining, guys. Our presentation for today is called Small Changes Can Make a World of Difference. And in order to explain why the presentation is called like that, I would like to start with a story. About a year ago, I've been to Italy. This picture was taken in the Amalfi Coast, and this is the view I saw from my balcony. As you can see, it's an amazing place. The only problem was that right at the same time TechEd 2014 took place, and SQL Server 2014 was announced. So I'm a bit problematic, and don't tell my wife because she's in the next room, but I had I had to start reading what's going on in SQL Server 2014. And I read this post from Brent Toller that pretty much explains the main changes, the main new things, new features in SQL Server 2014. So when I got home, I had a pretty good understanding about the big new features, and I started reading in order to see what other new features are there. So I started to read memory optimized tables, always on enhancements, yada, yada, yada. And right at the bottom of this second page, I saw something very interesting. I will zoom in, and if you can see here, there's something called sysdm exec query profiles. Sysdm exec query profiles monitors real-time query progress while query is in execution. So this sounded very, very interesting because this is something that we don't have right until now. So I went to an MSDN page and read what it said, and it said like this. Sysdm exec query profiles monitors real-time query progress while the query is in execution. The counters are per operator per thread. The data is collected, the data collected is serialized into the shopline XML when the query finishes. Use this DMV to monitor the progress of the query execution and determine where the query uses the most time. I think this thing is amazing because this is the first time we can actually see what the query is doing is in execution, in contrast to only estimated view we had up until now. So I blogged about it, and if PowerPoint will switch the slide, so I blogged about it, and other people blogged about it too, and there's been a lot of conversation about it on Twitter, and that's when I understood that a lot of times we pay too much attention to the big bombastic features like Always On or Hackathon or Quorum Store and so on, which are amazing features. Hackathon, for instance, is the state-of-the-art feature. But the problem with those features is that a lot of times it takes a lot of work and considerations before we can put it in production. And today I want to talk about smaller features that are easier to implement and can help us a lot. Okay, so 2 words about me because Sharon basically said everything. My name is Matan Jungman. I work as a technical evangelist at Madeira SQL Server Services. We're a consulting company based in Israel, but we provide our services worldwide. And what technical evangelist means is that basically I get to talk a lot and write a lot SQL Server and what Madeira is doing. So I currently blog at dbnewsfeed.com. I will probably switch to blogging at the Madeira site, madeirasql.com. I also have a podcast in Hebrew at SQL Server Radio COIL, and I'm on Twitter at Matan Jungman. So let's start. Our agenda for today won't cover always on availability groups, in-memory OLTP, aka Hackathon, and column store indexes. What we are going to cover is changes in the storage world and that affect SQL Server, tweaks we can do with performance tuning in SQL Server 2012 and 2014, features I call no-how attack features, which make our systems more predictable and reliable, and a small feature that can boost our productivity. So let's start with storage. So traditionally, our storage systems look basically like that. We take a spindle or a disk and add a few more of them and a few more of them, and we put them in a rack. And if we're lucky, we have some SSD disks also. And on the other side, we have our server. And we need some kind of cable or interface to connect between them. And this interface can be a bottleneck because the interface can be either USB or SATA or eSATA and so on and so on. And each and every interface has its limits. So a lot of shops started working in a way that all of the disks are actually inside the server. And that allows them to work a lot faster instead of working of constantly talking to the SAN through this interface. So we have basically the storage changes basically come from two sets of cards. One of them are the SSD cards, which made a huge revolution in contrast to our traditional drive. They don't have any moving parts. They don't have any arm that needs to go back and forth inside the drive. So they work much faster, especially for random I/O. If you compare the ROI of SSD cards for sequential I/O versus random I/O is much better. In contrast to regular drives. So the price is constantly going down. Each time I deliver this presentation, the price is going down. It started with about $1 per gigabyte, and now it's about 75 cents per gigabyte, and the price is constantly going down. And they can be grouped together to an array. So we can have some kind of redundancy in case one of the drives fails. The other type of card are cards called PCI Express cards or flash cards, and they work even faster than SSDs, especially because they work on the PCI Express interface. This interface actually is not suited for I/O, but the I/O companies like Fusion I/O and OCZ, they actually work on this interface, and they deliver extremely fast throughput. They are still expensive, about $2 to $5 a gigabyte, and they can't be grouped together to an array in contrast to SSD cards. But actually they can. The Windows Server storage team, Windows Server team in the Windows Server 2012, they announced a feature called storage spaces. It allows the grouping of drives to pools, and they have a concept called resiliency, which have three types: mirror, parity, and simple, which is essentially a RAID as we know it. And in the Windows Server 2012 R2, they also announced two features. One of them is tiered storage, which basically we can say this file sits on an SSD tier, and other files sit on the regular hard drive tier, and cold data goes down to the hard drive tier, and hot data goes up to the SSD tier. So this is very interesting. And another feature is called write back cache, which means we will always write to the SSD tier, which means our writes will be much faster. Let's say I want to put my transaction log on the fast tier. My writes to the transaction log will be a lot faster. And actually, if you install an Azure VM, Azure VMs make a lot of use of Windows Server storage spaces. Okay, so what's actually new in terms of SQL Server storage? So SQL Server also has some enhancements. SQL Server 2012 introduced the possibility to put TempDB on local drive in a cluster. Let's say you have a failover cluster. You have two servers. Up till 2012, TempDB had to sit on the shared storage. So this basically means that we had to go through the slow interface in order to work with TempDB. So now I can take TempDB, put it on the local drive, let's say PCI Express or SSD drives, and make it work a lot faster. SQL Server 2014 introduced a few more features. One of them is buffer pool extension to SSDs. I can have an SSD array, and SQL Server, when it drops pages from the buffer pool, instead of dropping them to disk, it will move them to the SSD tier. And then when I have to read them again, instead of reading from the slow mechanic disk, I can read them from the SSD tier. One thing to note about this feature is that only clean pages will go to the buffer pool extension. So if you updated a page and then it has to go to the it has to be flashed from the buffer pool, it won't go to the buffer pool extension, but to the actual spindle. Another feature is Resource Governor. Resource Governor was introduced in the SQL Server 2008, but it allowed us to control only the amount of CPU and memory a certain user or group of users can consume. And now SQL Server 2014 completes this feature and allows us to control the amount of I/O reads a certain user or group can consume, and we will see that in a minute. Another feature is delay durability, and as most of you know, I assume, a SQL Server has to be ACID compliant. ACID means atomicity, consistency, isolation, and durability. And the D part, the durability, means that each transaction has to be written to a physical media before the user gets a message the transaction was committed. The problem with this is that this makes things a lot slower. So delay durability means I can say to SQL Server, for this transaction or a database, work with delay durability. SQL Server will announce that the transaction has been committed, but it won't actually write it to disk. It will wait for a certain time or a certain buffer in memory to fill, and only then it will flash all of the transactions that sit in this buffer. And something that I recently saw is that TempDB bulk operations don't spill to disk. And what does that mean? Basically, up till SQL Server 2014, when we performed some bulk operations like sorting TempDB or select into a TempDB, those operations are considered bulk operations, and SQL Server flashed the pages of those operations quickly to disk for a few reasons. The SQL Server team made an adjustment in SQL Server 2014, and those pages won't be flashed to disk so quickly. So indexes that are built with sorting TempDB will be built much faster. I don't have a demo about the TempDB issue, but I encourage you to go to this page. It's called SQL Server 2014 TempDB Hidden Performance Gem. It was written by Bob Doe of the SQL Server team, and it explained this issue in detail. And actually, I saw Kendra Little posted that this feature will, at least a few parts of it, will be in SQL Server 2012 also. So this is awesome. Okay, and with that, let's see a demo. But before we see all of the I/O demos, let's see what SysDM exec query profiles can do, the DMV that I talked about at the beginning. So what I do here is I create a user called bad user, And I configure resource governor to allow a maximum amount of 10 IOPS operations per second, so that the query that I will run with a bad user will run a little slow and will be able to monitor it. And I create a classify function. Okay, and now I will execute a query. I will switch to my bad user. And I will use the database and create some kind of procedure. And I will clean my cache and execute the procedure, and I will open the monitoring file. So this query goes to sysdm exec query profiles, and let's see what it can do. And I forgot, in order for sysdm exec query profiles to work, I have to include the actual execution plan, either by lighting it here, or by collecting it in profiler or ENHANCEMENTS, which of course can cause a lot of performance headaches to the system, so beware of that. So we execute it again, and let's see what we can see here. We see node ID, thread ID. We see the physical operator name, and we can see the row count. And if I start refreshing, we can see that node ID 10 starts to process rows. We can see the row count going up. I will zoom in, and we can see that the row count starts to go up. So what's this node ID? I will click here and go down, and we can see that node ID 10 is an index scan on the big transaction history table. So basically what we can see here is that SQL Server now operates this operator. And then when other nodes will start processing rows, we'll be able to say this query performed this operation up till now, and now it performs this operation. And this is the first time we can actually do that. We had this ability, we could do it kinda with CX packet weight, but this is a huge difference and a huge leap from what we had up until now. And we can do a few more things because this DMV shows us granular information per node ID and thread ID. So let's say I can group the operations by physical operator name, and I can see node ID 10 processed such and such rows, and node ID 9 performs operated on 8,000 rows, and so on and so on. And I can also join to other DMVs in order to get some more information. Let's say I want to get the text of the procedure that is executed. I can do that using sysdm exec SQL text. So I think this is amazing, and as more and more SQL Server 2014 implementations will be in the field, and there will be some more queries and more best practices on how to use this DMV. Okay. So now let's look at our storage enhancements. Okay, what I forgot to do, I forgot to perform a cleanup, so we'll do that. Okay. And now let's talk about storage improvements. I will limit the amount of memory my SQL Server can consume to 500 megabytes. And I will now configure the buffer pool extension array. I define one file with the size of 4 gigabytes, and that will be my buffer pool extension. I don't actually have an SSD array on my PC, but SQL Server doesn't know about it. But it will be kind of foolish to do it in production if we don't actually have an SSD array. And I will create the login again. This is the same login. I see I have some kind of problem. Yeah, I think I connected with the bad user, so let's wait a few more seconds. Yeah. Okay, let's connect with the new connection and try that again. Okay, and I will configure resource governor again, and my classifier function. Okay, so now I will execute a query. I will clean the buffers and execute some query on the system. And if you go to perfmon, we can see that this queries a second of about 130. Basically, I can perform basically 130 reads per second. Okay, so I will stop that and clear the cache, and I will take this same query as the bad user. So I will open a new connection. And use AdventureWorks 2012 and execute the query. And when I go to perfmon, as you can see, we don't exceed the 5 IO per second limits. So this is resource governor. For the first time, we were able to limit the amount of IO a certain user or group can consume. So this is very nice for consolidation environments and so on and so on. Okay. So we'll execute the query again. And stop it. And SysDM OS buffer descriptors, that's a DMV that has been around for a while, but it has a new column called isInBufferPool extension. And if I stop the query and execute the new query, I can see that we have right about 9,000 pages already in the buffer pool extension. So SQL Server had to flush some pages from the buffer pool, but instead of sending them to disk, it sent them to the buffer pool extension. So buffer pool extension has a few more things we can look at. It has the SysDMOS buffer pool extension configuration, and it also has some performance counters, extension page writes a second, page reads a second, and so on and so on. So this allows us to monitor the behavior of SQL Server and the buffer pool extension. And I will perform a cleanup. And we'll move on. Okay. So speaking of storage improvements, if you go to this link, bit.ly/don't defrag, you will be redirected to a presentation by Brent also called Why Index Fragmentation Doesn't Matter. And Brent basically spanks us in the head and says, stop rebuilding indexes automatically because things have changed. SANs have more caches. Disks are much faster. And for a lot of other reasons, the automatic operation of rebuilding an index is not always needed. So I encourage you to go to this presentation. And with that, we move to performance tuning. And I want to recommend another presentation, bit.ly/parallel plan. And if you go there, you will be redirected to a presentation by Adam Mechanic. It was presented in PAS Summit 2012. And it's an amazing presentation about how to use parallelism. As we already said, disks are much faster now. We have much more memory. We have a lot more CPUs. And we have few more options to play with when we tune queries. It's not always just I/O, I/O, I/O. There's a few more things we can do with parallelism in order to make our queries faster. And let's see a demo about that. Okay, so I'm actually starting to work in SQL Server 2012 mode, and I will tell a little later why. So we'll use our database. And for a start, we'll create a temp table, and insert some data. And if the demo bot is with me, it will take about 7 seconds. Yes. Okay, so if you look at the execution plan, we can see we have some parallelism objects in the query, which made this query run faster. I will now do the same thing, but with a table variable. And that should take about 10 seconds. And we can see our plan is not parallel. Table variables don't allow the query to work in parallel. So this is something that is added to the ongoing debate of temp tables versus table variables. Take this into account. Another issue is function parallelism. I have the same query here, but what I do, I use defined functions that all it does is return the input. And I will execute it again. And it takes right about 10 to 12 seconds. And again, it's not parallelized. It's not parallel. And if I go into the show plan XML, we can see here, I'm looking for it, we can see something called non-parallel plan reason. And SQL Server says I couldn't generate a valid parallel plan. So if you work with table variables or with use-defined functions, take into account that plans cannot be parallel. We have other reasons, max dop set to 1, for example, and estimator dop is 1, and a few more. And now we can write queries that will show us what queries are expensive and could be parallel, could be improved by being parallel. So what I do here is I go to sysdm exec query stats and cross-apply to sysdm exec query plan, and I search the word non-parallel plan reason in the execution plan XML. And when I execute that, we can see our query here. And when I push show execution plan XML, we can see the non-parallel plan reason. Yeah, there it is. Okay, another improvement is select into parallelism. If we work with compatibility level of 110, that's SQL Server 2012, and perform some kind of select into operation, right about now, we can see that the plan is parallel, but the insert part is not. So this is something that was improved in SQL Server 2014, and we switched to compatibility level 120. And when I execute the same query, we can see that the insert part is parallel also.
Matan, have we lost audio?
Sharon?
Yeah, okay, I can hear you again. I wasn't
I
getting any audio.
I apologize, guys. Something went wrong with my internet connection.
Those things happen.
Okay, so sorry about that.
That's
Let's
okay.
continue. Okay, so when did you lose me?
You had just shown the execution plan for the showing the insert in 2014 being parallel as well.
Great. So select into the insert part of select into can be parallel also, and this can be a big benefit if you perform select into on large result set. So let's continue. SQL Server 2012 added another feature which is execution plan warnings. Let's say we do something wrong with on our queries, SQL Server can alert on the execution plan. So let's see. I will create some table and insert and create some index. And when I perform this operation, it will cause a converting implicit operation because I passed a Unicode at a Unicode value, and the table has a voucher value, a non-Unicode column. And if I look at the execution plan, SQL Server has this small mark here that says you did something wrong. And if I go to the execution plan XML, where is the warning? I'm sorry. This is the warning part, and we can see we have some kind of convert implicit operation. And of course, the way to fix that is to use the right data type, and then I don't have any problem. Another example, let's say I accidentally perform a cross join. If I look at the execution plan, SQL Server has this big red mark here that says, boy, you did something wrong. And now, just like I did with parallelism, I can do the same thing with warning. And I can see queries that have some kind of problem in the execution plan, and they are in the top 20 offenders in terms of I/O. And here we can see our query. Okay, and we have some other warnings, column with no statistics, built to TMDB, and so on and so on. Okay, SQL Server 2014 also has a new cardinality estimator. The cardinality estimator is the part of the when SQL Server has to perform a query, the first part is to generate a good enough plan. And this plan is comprised out of a few engines. And one engine is the cardinality estimator. And its role is to estimate how many rows we'll get out of each operator in the plan. So let's say we have three queries here. And we can see that the estimated number of rows here is about 5 million. The estimated number of rows here is about 100,000. And the estimated number of rows here is about 3 million rows. So what SQL Server does, what the cardinality estimator does, is it computes the selectivity of each condition, or each column. So it divides 6 million by the number of rows in the table, and gets this number, and this number, and this number. So the old cardinality estimator just took these cardinalities and multiplied them one by another. And if we execute this query using, when I use this trace flag, it uses the old cardinality estimator. So when I execute that, we can see that it estimates that it will get about 1,700 rows, and the actual number of rows is 18,000. So the new cardinality estimator, it takes the cardinalities and works with a different formula. It works with square roots. It takes the most distinctive column and multiplies it by the square root of the second distinctive column, and so on and so on. And when I execute this query, we can see that in that case, the estimation was a lot better. The problem is that it's not always true, and it's our job to check whether or not our plans are better or worse when we upgrade to SQL Server 2014. If you upgrade to SQL Server 2014, by default, the compatibility level will stay 110, which will SQL Server 2012. When you alter the database to work with compatibility level 120, it will start working in the SQL Server 2014 way. And we'll move on. Okay, so we saw performance tuning goodies. I'm sorry, I speak a little faster because of the internet problem. So we have non-parallel plan reason in the execution plan and warnings, and SQL Server 2014. We have select interparallelism, indexes on local variables. In 2 words, when you define a table and the column, you can define an index on that column, and that allows us to have indexes on local variables. I don't assume it helps too much, but it's something worth checking. And of course, the new cardinality estimator and CSDM exec query profiles. Okay. And now we move to the features I call no heart attack features. And I call them no heart attack features because they make our system more predictable and allows us to execute some kind of operation with more certainty about what will happen. And let's see what I mean. So SQL Server 2012, partition switch lock starvation is prevented. Basically, the problem was that when we wanted to switch out a partition and we had a lot of node queries that were running at the same time, basically no lock actually puts a lock on the table. It puts a schema lock on the table. And in addition, it doesn't, it passes the line. It doesn't stand in the line of locks. So basically, if we have a system that constantly queries the table we want to switch out with no lock queries, we won't be able to perform the switch out because the switch out will be blocked. So SQL Server 2012 solved this problem, and no lock stands in line. And another addition is that online index operations are supported for tables with lob columns that wasn't supported up till 2012, and the addition of a non-null column with a default value is now a metadata operation. Basically, up till 2012, if you wanted to add a column with a default value to a table with 50 million rows, you had to go row by row and insert or update it with a new value. From SQL Server 2012, this is very, very different. Let's see that. So I have here a table called Big Transaction History. This is a table. Adam Mechanic has a procedure to make adventure works bigger. He calls it Big Adventure Works. So this table has about 31 million rows. And I'm on SQL Server 2014, and I want to add a default column with a default value of 0. And this takes place instantly. And this is because this is only a metadata operation. If we go to, we have some internal tables about it, and if we go right to the right here, we can see we have a default value of 0 for this column. Unfortunately, this is an enterprise edition only feature, so sorry about that. Okay, SQL Server 2014, no heart attack features. We have partition level online index operation. Basically, if we have a partition table, we were able to build a specific partition or build the whole table online, but we couldn't build a specific partition online. Rebuilding this partition blocked the whole table. So now we're able to do it in SQL Server 2014 with this syntax. And we have something called block priority for partition switch and online builds. Let's say we still have a blocking problem that blocks our partition switch operations. We have something we can do. Okay, so we have when we switch out a partition, we have something called wait at low priority. It basically says, SQL Server, if you're blocked, wait for X minutes, and after that you can perform one of the following: either kill all of the sessions that are blocking me, or kill yourself. So let's see a quick demo. I go to the big transaction history partitioned table and execute a select star from it. And now I say alter table big transaction history partition, switch partition 1 to the switch out table, wait for 0 minutes, and kill the blockers. Of course, I can say wait for 5 minutes, and so on and so on. So when I do that, and I go to the other session, I can see the session was killed. If I execute that again and use the kill self operation, I will wait for 1 minute, and if the operation doesn't succeed in 1 minute, I kill myself. For some reason, I can't do that. I can't wait 0 minutes for myself. Not sure why, but be aware of that. And of course, as we saw, we can build a specific partition while killing the blockers as an online operation. And I build partition number 1 as an online operation. And I think we'll move on. Some more partitioning goodies really quick. Right from SQL Server 2012, we are able to work with 15,000 partitions instead of the 1,000 partition limit that was before that. Statistics on partition indexes don't scan all of the rows. SQL Server assumes that each partition has a lot of rows, and it doesn't need to scan all of the table when you build partition or statistics or indexes. In contrary to regular tables, if you have a very big table and you have the same table that is partitioned, if you look at the number of rows that were scanned by the statistics, the partition table will show a smaller number. And something that is called incremental statistics in SQL Server 2014, basically when each partition passes a certain workload, statistics will be recalculated for this specific partition. This is not on by default. You have to turn it on by using some kind of syntax of incremental statistics. One thing to note is that we still have one statistics object for the whole table. SQL Server will calculate the statistics for this specific partition and merge that to the big to the statistics object of the table. And now, really quick, I want to talk productivity. I won't show the demo, unfortunately, because we really out of time for now. But I want to talk about a specific feature that was introduced in SQL Server 2012, and it's called SQL Server 2012 Management Studio Snippets. Let's say...
Matan, you don't have to worry about
yeah.
time. We can go a few minutes over.
Oh, great. So, great. So I will demo that because this feature is something that is very dear to my heart. So I will demo that. So basically, let's say you have a certain query or a certain operation that you perform 10 times a day. I know I have those queries, and all the time I either have to type it or to find the file that I put it, or Google or Bing that. And instead, SQL Server Snippets allow us to save this script, and we can also parameterize it and use it on our day-to-day work. And it allows us to be either lazy or efficient. You can decide, you can choose your definition for that. And let's see a demo. So I close that. Okay. So just for the sake of a demo, I will execute some kind of query here, and I will begin a transaction and execute this query with tablock X. And we will have 3 processes that will be blocked by this operation. And now let's see. For a start, let's say I want to see how many rows I have in a table. So of course, I can do a select count star, but this is very inefficient. So what I can do is I can type big transaction history, and I can right-click and hit surround with, and choose my code snippets, and choose count rows. And instantly an efficient query is generated. And when I execute that, I get the number of rows instantly. And that's something I execute a few times a day, at least me. And we also have keywords shortcuts for that. So if I hit Control KF and hit my code snippets and count rows, and this is much more efficient than starting to type. We also have another type of snippet that is an expansion snippet, and we hit the insert snippet or Control KX, and when I hit Control KX and choose my code snippets, I can choose show current running queries. And when I run that, I can see I will 3 updates running, and they are suspended, and they are blocked, and I can see they are blocked. 2 of them are blocked by session 53, and 1 of them is blocked by session 52. But session 52 isn't currently running. So I type 52 and hit Control KS, choose DBCC input buffer. And the DBCC input buffer command is generated, and then we can see the process began a transaction but didn't commit it. So now I can just kill this offender, and the other process has finished successfully. So I have quite a few snippets I wrote. Let's say you want to measure your I/O latency. So what I do here is I take a snapshot of system I/O virtual file stats and sleep for 1 minute, and then select from this DMV again. And this shows me, let's say, I will just wait, let's say 5 seconds. Just for the sake of this demo. 1, 2, 3, 4, 5. And we can't see anything here because we didn't perform any operation, but on your production system, you'll see the database name, the number of reads and writes, and read latency and write latency. And that can be a starting point at watching, at checking if you have an I/O latency in one of your database files. Okay. So action items, I encourage you to take. Go over the features we went over on this presentation and implement them because, as we said, I guess no one will go and implement Hackathon tomorrow because it takes too much time for consideration and implementation and planning and so on. But those little features we saw are much easier to implement. Take time to watch Brent and Adam's stuff. I think those are amazing presentations. And be lazy. Go to dbnewsfeed.com/snippets and download my snippets and use them and have fun. And thank you for listening.
Thank you, Matan. There's a couple of questions. First of all, there's always a question about the recording. The recording will come on dba.sqlpaths.org. It'll probably be there this afternoon. Go to the meeting archives page. There's a request for whether we can get your queries for testing and learning. If you're willing to send me the code, I'll put it up on the meeting archives page.
Of course I will.
And then Mark just asked if there was a way to export snippets from server to server. And it seems if you can download them from your blog, it must be possible to move them from server to server, but how do you do it?
Oh yeah, I forgot to show that. So basically, I will show that real quick. If you go to C users and your user in the machine, and let's say you connect to a lot of machines, you will have your user on each machine, and go to My Documents, SQL Server Management Studio, and Code Snippets, SQL, My Code Snippets, and you'll see the snippets there. You don't have to remember that. If you go to my blog, the blog post dbnewsfeed.com/snippets, if you go right to the bottom, you can see this path. Okay, and you also have something called Code Snippets Manager, where you can take a snippet and import it, but all it will do is copy it to this location. But you will need to copy it to each and every server you connect to or work to. That's something they didn't solve. And I hope that answers the question.
Okay, thank you very much, Matan. I made lots of notes. I'm going to be writing a course on new performance features in SQL Server 2014. And while I think I've got my 3 days full already, now I have a whole bunch of stuff I want to add. My outline is already 3 days full. I haven't had the planning meeting yet, so we'll see.
So I'm glad and sorry I added more work.
Oh, well, that's okay. It's great because it's my favorite subject. And I thank you for coming, and please let me know if you have other talks. And all I have to do now is announce our raffle winner. It's Ranjit Nair at ansira.com. Headquarters will let you know about your gift card and send it to you. It's all electronic. So thank you all for coming. We'll see you in the, I think it's June 11th. I've forgotten who the speaker is, but I'm sure it will be interesting. I'm going to end the meeting now and not what I wanted to do.
Okay.
And stop the recording.
Thanks again for having me, Sharon.
Thank you for coming. It's great.
Thank you. Have a great day.
You too.